Welcome to the, I guess this would be the summer solstice edition of the VLab Forum. A little bit delayed. We are yet in another of our totally virtual VLab Forums coming to you virtually. Our studios are virtual. Everything's virtual, but that's all good. We got a great topic today. The Winter Storm Severity Index, which has been a project being run out of WPC and the Weather Service for quite some time. A lot of interest in this, focusing on IDSS in the winter context, objective type of tool guidance to support this really critical winter weather phenomena in IDSS business area. We will remind everyone that the VLab Forum is recorded, so we will be uploading the recording of this to the VLab Forum website shortly after the conclusion. Our format is about 30 minutes of content and 30 minutes of Q&A, so please save your questions for the Q&A session. When we get to the Q&A session, please use the raise your hand feature to indicate you'd like to ask a question. John Chattel, our technical production manager, will unmute you and you can ask your question directly to our speaker, Joshua Kastman. Or you can use the chat feature to type in your question if you prefer, in which case we will relay that to Joshua that way. Our purpose in the VLab Forum is to look at new things coming down the pike for Weather Service operations, either in the early stages, middle stages, or maybe even rolling into operations, so that the transition to operations goes smoothly and we can exploit the new tools to their maximum potential. So today we're very privileged and lucky to have Joshua Kastman giving the presentation. His co-presenter on this project is Jim Nelson, who a lot of us know very well. And without further ado, I'd like to hand over the steering wheel to Joshua.
Thanks, Steve, for that introduction, and thanks to you and John for the invitation and the opportunity to present today. I'm really looking forward to engaging with you all today. So we'll go ahead and get started. First, I want to say there's no WSI without Andy Nash. He's the original creator and developer, and we just really appreciate everything that he did and continues to do. He's still an active contributor and collaborator with us. So thank you, Andy, so much for everything. I'd also like to thank Dan Cobb and Mike Maselli, and among the other original developers who laid the foundation for WSSI for. They did a great job laying a solid base for us to work on, and we just continue to move the ball forward. So thank you to all of those original developers and creators. Thank you. I'd also like to thank Ian Lee from the Detroit office, who he was on an NRAP at WPC for 6 or so months, and he did a fantastic job helping us get our VLab page VLab pages set up, including the WSSI page. So big shout out to Ian, and thank you for all your hard work. So just as an overview of the product, I know for some of you this may be your first exposure. For some of you who might be daily users of this might be a little bit of review, but the overview of the product is to summarize multiple winter weather impacts from a storm into an easily consumable graphic. We are using a 72-hour forecast data set that's broken down currently into 24 hours. So you'll have a day 1, day 2, and day 3 option, as well as that 72-hour composite graphic. The data is coming directly from the National Weather Service Digital Forecast Database, and it is updated every 2 hours. The summary graphic that you'll see on the home page is a composite of the maximum impact from any of the 6 components. And those 6 components, which we're going to dive into the details about those components here in a second, are snow amount, snow load, ice accumulation, blowing snow, ground blizzard, and flash freeze. You'll see up above right, that is our definitions and color scale for the WSSI, ranging from no impacts all the way to extreme impacts. So without a doubt, the most heavily used or most frequent showing up component of the WSSI is the snow amount index. It's kind of the driver of the WSSI overall. And this component is designed to highlight areas in which impacts, especially to transportation, could overwhelm. And there's two main factors that go into the snow amount index. The total amount of accumulating snow, which is run through a 2-day climate storm. You could think of it as a storm-based climatology, which I'm going to go into some more details there. And then the rate at which snow is falling. So a couple of things on these points. The first with the total amount of snow, and particularly the climatology. So this is designed so 2 or 3 inches in the southern regions are going to show a much bigger impact than say 2 or 3 inches in the central part of the U.S. or the Great Lakes, in places where you would expect lots of snow. So it's tuned for that exact reason. And then on the second point about the rate at which snow is falling. So while this is taken into consideration, you have to remember we're using a 6-hour data block. So very frequently, the snow amount has more of an impact than the rate of snow because the rate is washed out over a 6-hour block. Now we have some exciting stuff coming up that maybe we will be able to unlock this part of the snow amount a little bit more, and I'll get into details about that upcoming. The snow load index is probably exactly what you would imagine it to be. It highlights the area where you're talking about really low snow to liquid ratio snow. So when you have a really heavy weighty snow, this index is going to be have an increased impact. And one of the cool things with the WSSI, there's a lot of land use taken into consideration. And in this index, particularly what we pay attention to is the forest type. If the snow load is happening in a heavily evergreen forested area, the snow load is not as impactful because studies have shown that it takes quite a bit more heavy wet snow to impact the evergreen trees than say a deciduous forest, especially a leafed out deciduous forest. So those are taken into account, time of year and forest type for the snow load index. For instance, the same kind of snow load, an early season snow load is, a 6-inch early season snow is going to have a higher impact than say a midwinter storm because we're taking into account the leaves. The next two components I'm going to talk about are the blowing snow and ground blizzard. The blowing, these both are really getting at the same thing, resuspended snow or just suspended snow being blown around and causing a reduction to visibility. So the difference here is the blowing snow is occurring when it's actively snowing. So you can think of the blowing snow index as, if you have a true blizzard situation, this index is going to light up. We've seen this in past cases this past year in April, and in 2018 we saw this really light up in that historic March blizzard across the high plains. So this is, once again, think when blowing snow starts to get really aggravated, that's when you're having those active snow situations with strong winds. Pardon me. With the ground blizzard, that is more of a situation where you have freshly fallen snow and then an increased wind field moves over that region to resuspend the snow. And once again, the hazard with both of them are going to be similar, reduced visibility primarily being one of the primary threats here. And once again, land use is taken heavily into account for both of these parameters. For instance, if you're in a grassy area or a cropland-based area without many trees, the reduction of the wind is going to be very minor, so you should see more of an effect from the blowing snow. And then finally, the last two indices to discuss here are the flash freeze index and the ice accumulation index. The flash freeze index is here to depict severity primarily to transportation for situations where temperatures rapidly fall below freezing during or just after precipitation. So, imagine the scenario where you have either rain or snow falling above 32 degrees. Regardless, there you're left with wet pavement. And if the temperature drops below freezing, it's a situation where ice can rapidly develop. That's what this index is looking for, is for areas where there is still liquid available on the ground and then a rapidly falling temperature field to create ice. Now, we're going to get into the flash freeze index a little bit more in depth coming up. because there is some limitations with that because we are restricted to using 6-hour QPF data. So we've made some modifications from the original formulation to account for the 6-hour precipitation blocks. But still, this index, what it's trying to communicate is where are there regions where there should be liquid water available to freeze due to a drop in temperature. And then finally, the ice accumulation index. This component is here to account for not only just ice accumulation, but any wind on top associated with that ice as well, which will have a widespread tree damage and transportation issue among other impacts. So those are the 6 core components of the WSSI. And this is an example of a case that happened back in 2019 across New England. So what we see here is an image of 3 distinct regions of major impact. And we can see that these are driven by 3 different occurrences, actually. Across New York here, in the New York area, we see in this blue encircled area, the primary driver is snow amount. But that still leaves us with 2 areas unaccounted for major impacts. We see the area here encircled in the darker blue is actually driven by snow load. But we still don't know what's going on across southern Massachusetts into Connecticut and Rhode Island. We see here that that's actually associated with ice accumulation. So this example does a nice job highlighting how in certain situations, it might be nice to just message there's going to be major impacts. But for some partners, it will be better to probably drill down into the details to show why there's these impacts happening, whether it be snow amount, or in this case, not only snow amount, but snow amount, snow load, and ice accumulation. Many of you may have seen this before as well. In 2019, we transitioned from more of the stoplight color system into this yellow to purple impact regime as far as the colors are concerned. Colors, I know it's always a big thing with the Weather Service, but we made this change to better match ongoing hazardous efforts throughout the Weather Service. And another big thing you'll see here is our definitions are more generalized to talk about the inconvenience to daily life, as opposed to on the previous definitions, it was a lot focused on thresholds and criteria levels. We're trying to get away to that and focus more on the impacts. Excuse me. So these changes came about after some social science engagements with National Weather Service headquarters, including Jennifer Sprague and Daniel Meagle, Greg Shore, myself, and Jim Nelson, among others. We matched the color curve to, as I said, to the other NWS efforts, and we reworked the definition, the impact definitions. Excuse me. So moving on into some of our VLab information today. You can't go to the VLab Forum and present without at least mentioning your VLab page, right? So we're very excited. We're really starting to use VLab more this upcoming season. As I mentioned before, Ian Lee did a great job helping create this page for us. And I wanted to point out a couple of features that maybe users might be really interested in. So if you go to this image viewer tab on our page here, and this page I should mention is findable. If you just go to the either the WPC VLab page, this is an option to get to the WSSI page, or you can just use the main search feature and look up WSSI, and it should direct you to this page. So on this image viewer page, on the main display, you'll see a looping 3-day image of just our static images. But as I have encircled here, pardon me, and this select WFO feature, this button will take you directly to whatever WFO you're interested in, WSSI homepage. So it'll be a nice zoomed in feature on the interactive map for the WSSI. And then finally, in this additional data section, this might be the most useful thing we have on the VLab page right now. This is a direct access to our archive page. So here, using the calendar tool, you can actually just select the date that you're interested in, and it'll take you to that to the directory that houses that day's information of the archive data for that day. And there you'll find not only the CONUS perspective, but each WFO's static image for the day. This page also houses where the links to the KML and shape files for those of you interested in using GIS to investigate the data. There's no that data is only current. We currently do not have a GIS archive. That's something we are working towards. I also wanted to discuss real quickly the WSSI website. So there's several features on the interactive page. Well, the great thing with this, there's clickable tabs that you can use. If you were to click on any of those tabs across the top there, they'll take you directly to those images right on top of the interactive web map. And as well as you can click these sub tabs beneath it to move either to look at the full day 1 through 3 period or the individual days themselves. In the blue and the green area here, you can use that drop down to zoom to the individual WFOs as well as the FEMA. There's some FEMA level zooms as well, so you can just focus on a FEMA region if that's your interest. And in the navy blue encircled area, you can actually create a PDF with whatever you're viewing on that map. So there's going to be some options that I'll talk about on the next slide to change what is on the map overlay, or what's overlaid on the map, and you can use that print button to create a PDF of whatever you have selected. There's also in the yellow area a drop-down box to switch whatever base map that you're using. I know many users like the dark gray or light gray backgrounds, and you can control all that using that switch base map tool. And then finally, there's some direct links to the GIS data as well. The KML and shapefile directories are data are available right through those links. The map overlay options, as I mentioned. So with those, there's a few different options here, including the CWA, states, FEMA, RFC, counties, public forecast zones, the ARTCC zones, as well as metro areas that you can turn on or off on the map and see the data still with those different options checked. So real quickly, I'll go through some of the changes to the snow climatology. And this is still basically the system that was used in 2018 with just some minor tweaks and improvements. And those improvements came based off of field requests. So we made some adjustments there to make everybody more comfortable and to improve it. So this year, a little bit more quality control in the data. All of the data that's used comes from the Historical Climate Network data set, which there is some level of quality control there, but we added a couple additional of quality control measures this year to ensure that the highest quality data was being used. So this reduced the number of stations from the 2018 climatology, but it also influenced the first order stations. So that was good. So there's about 3,900 stations in this climatology. And the biggest change here is that we're using the average of max plus mean 2-day snowfall. And what is the goal of that instead of before where we were just using the maximum snowfall? So this increased the correlation to minor and moderate thresholds. And it also reduced, the main goal here was to reduce the minor threshold in snowy regions such as the Great Lakes and Intermountain West, where it was too hard to reach the minor threshold. This really didn't change the minor threshold at all for the central or southern U.S., but it did help out in those snowier regions. And once again, that was all brought about because some of the NWS offices directly reached out and said the minor was too hard to achieve. There was also some regression changes this year, just the way the data was binned this year in the regression modeling. I binned it by the river forecast under boundaries and while using the same regression variables as before, including annual snow, elevation, and latitude. And that weighting improved the results a little bit, especially where different regions had similar statistics. So that was just some influences there on the edges to help increase the quality of the climatology a little bit. And as a result here of the climate, I just wanted to show you the difference between the moderate criteria, which you'll see on the right, versus the winter warning criteria. Now, remember, our intent is to not have these be identical, but just as a gee whiz, here it is kind of image here. On the left, you have the 24-hour NWS criteria. On the right, you have the moderate WSSI amounts. And you'll see there's some differences in this data set, but what you'll also notice in the WSSI imagery here, you don't see geopolitical boundaries. The data is the data, and there's no hard stopping lines because of either NWS boundaries or mountain zones, which I know are very difficult to try to work with, especially with these criteria maps. So anyway, this is what the moderate looks like. And then finally, digging into the flash freeze component here. So the original formulation of this called for hourly temperature data to be viewed with the QPF data. This caused somewhat of an issue because the QPF data from NDFD is a 6-hour bin, whereas temperature you can get in an hourly chunk. This would cause a lot of problems, especially in fall and spring cold fronts, where you'd have prefrontal rain occur at basically hour 1 of a 6-hour block, and then a major temperature drop occurring in hour 5 or 6, where in reality you'd have a lot of evaporation with the QPF, and a lot of that was gone by the time that the cooler temperatures arrived. But what we saw some kind of wacky looking signals at times if we had very strong cold fronts. So in order to combat that, we made some adjustments to the flash freeze algorithm using a 3-hour average temperature change instead of an hourly change. What this did is it capped the flash freeze essentially to a moderate impact. And it also, what it also did was it removed some areas where there was over alerting that was going on, and where things were barely meeting the 6-hour QPF threshold. A lot of that's been removed by using this 3-hour average temperature. Now, this does not fix the core of the problem, which is using 6-hour QPF. We are looking into that as just kind of a teaser here. We're working. I've got a couple more slides on this coming up, but we're going to be working with an experimental version of the WSSI this year using the MBM as an input. So we will be able to use hourly data and take a look at the original flash freeze algorithm using that hourly data instead of the 6-hourly QPF data. So here's an example of the changes that we're seeing in using the new flash freeze algorithm. We see here in the Kansas City area a reduction in coverage, as well as across Montana and Wyoming here, a major reduction in intensity, which is what we were looking for. So now that kind of focuses ends what we've done. Now the next part of the presentation is really where we're at and where we're going, which is starting to get really exciting. So first off, I wanted to talk about the survey results real quick. This year we had 76 public survey responses. This was less than last year, but we definitely attribute that to that. It was a less intense winter, especially out east. There was just a big fat nothing going on for most of the winter, much to my dismay. I'm a snow lover, so it was upsetting for me. And we also think the pandemic definitely ate into some of the March, April responses. But for what we did get, we still had very positive. We had a very positive survey with 81% of respondents coming back favorable. And the internal survey, we had 29 responses. Then, as of last week, these were more event specific. So these were for offices to really do a review of the WSSI on specific events. And they tend to focus more on the time of the day, commute, and the commutes, which was interesting. And then, of course, with any NWS office, there was lots of model discussion, even with this product. So that was interesting to see. This year we did we did word clouds on the survey results just to see what stood out. And on the NWS survey cloud, what was interesting is snow and snowfall, the component which we think of as the most important. showed up in the survey results, which was very interesting to see. We do see impact was there, and what was also interesting was the actual categories of impact, minor, moderate, showed up as well. So that was interesting to see. And then we also did we put the public survey results into a word cloud. And one thing that made me very happy is the largest word was impact. So this is an impact graphic, and the survey results focused on impact, which was very interesting. And another word that I like to see there was easy. So easy and impact, that made me very happy to see as far as which words stood out from the public comments. Some highlights of use and visibility from 2019-2020. So Amazon is using this product very frequently. We had a meeting with their lead intelligence analyst, and he revealed to us that they use the product, they like the product because it gives them a quick overview of where the weather's going to be bad for their distribution centers. And they love it because it has GIS data associated with it, so they can feed it into their GIS systems, and it makes their life very easy. So that was a fascinating conversation Jim Nelson and I had with the folks at Amazon. We also had some positive press written this year. The Washington Post Capitol Weather Gang wrote an article on the WSSI. The Weather Channel also wrote an article on the WSSI. And then the very popular weather tool website, Pivotal Weather, now actually uses has a WSSI section. And another thing that we're excited to see is TV stations are starting to use the WSSI. They're using the KMLs to create graphic packages. The example you see here in the lower right was actually from Texas. So it was cool to see this kind of pop up naturally without us even really pushing. So that was cool. So what is in the WSSI version 2.0 that was implemented this October? So that's the 72-hour summary and component graphics, the various base zooms, the 24-hour breakout, GIS data, and the flash freeze and updated climatology. So that is what we are considering the current version of the WSSI. The version 3.0, which will be another experimental version that we'll be working on this fall, is going to have the rolling 24-hour summary and components. So think of this similar to the other WPC products where you have a 24-hour forecast kind of updating every 6 hours. And that's in development. Extending the WSSI beyond day 5 is another goal. And our first shot at that is using the MBM model, the deterministic forecast. Another thing that we're excited about is ArcGIS Online Services. The internal service was created this year, back in April, thanks to Nipa and her team. So there's a link here in this presentation it's internal only at this time, but there is some REST services for the WSSI. And as far as collaboration, we have a fantastic WSSI national team. It's made up of WFO and regional representation. We have a very active team that we meet at least once a month. We have a lot of really, really great folks on there that are hard workers and really helping us make this better. So we really appreciate all of our team members for all their fantastic help and making this product better and better. We also had some really great feedback from NWS offices and regions in the last year, and working with them has helped us lead directly to improvements. So we appreciate all those who've reached out. And a thing that we're very excited about this upcoming year's training materials. We're going to be working with WDTD this summer on a training course, and so look for that later this fall, later this summer, early fall is when that's scheduled to come out. One of the new things we're working on is the probabilistic WSSI. So what this is going to show eventually for all of the components, but just for right now, it's just the snow amount, is the probability of exceeding WSSI snow amount criteria. So we actually launched this page. It's internal right now. It's linked off of the WPC Winter Weather Desk internal page back in February. And what this does is it uses the WSSI snow climatology threshold and runs it through the WPC PWPF to generate a probability. more probabilistic components are coming, but right now we're starting with the snow amount, and we've gotten some really great feedback on this from our forecasters at WPC and from field forecasters. That they really like to see this probability of impact, and that's what we're aiming for towards in the future, is getting to that. What's the chance of a moderate or a major impact? So that's something we're really excited to be working on right now. The all-component probabilistic version of the WSSI is something that I'm actively working on with other developers at WPC, including Bruce Steenhouse right now. So what this is going to look like is we're going to start with the PWPF because we have control of the output right now for that particular ensemble. And we're going to look at this through two different methods. We're focusing on method 1 right now. And what that'll look like is each member will have its own WSSI forecast with a probabilistic output from the full ensemble using those individual components. And the forecast will be out to day 3.5. The method 2 option is a joint probability method, where the probabilities would be derived from the raw components and then put together from there. Like I said, we're working with method 1 first to see how that looks, and then we're going to move forward from there, depending on the results of this summer's experimentation. Another thing we're very excited about that I'm going to be implementing later this summer is a 30-meter land use classification, and that data source is the Multi-Resolution Land Characteristics Consortium, the MRLC. They work with USGS and NOAA to create these imagery sets. In the past, we have been using a 5-kilometer land use classifier, which was good for the time, but in 2016, this new land use classification was released, and this summer we're going to try to incorporate that into the WSSI, so we just have some more refined areas for where should the forest really start and end. Where's the urban areas really sprawling out to? So we're excited to use this higher resolution land use. It's going to help things in the east, certainly, but out west, it's going to really be a game changer as far as forest coverage and open areas, things like that. We're really excited to incorporate this high resolution data set into the WSSI. And actually, as you see here, there's also some areas above the tree line. This has been a concern for some of the Western offices to how to handle these areas above the tree line. Using this high resolution data set is going to allow us the ability to figure out a way to how to handle those regions. We're working with some of our Western region reps right now on the best way to do that. So going forward, we should have some more information on that. So a model-generated version of the WSSI is also planned this fall in experimental mode, not in operational mode. I want to stress that. This will be a prototype version of the WSSI. And we're going to start by using the deterministic MBM as a proof of concept. Some really cool stuff is going to be able to happen because we're going to use this high temporal resolution model. One of the most sought after things with the WSSI has always been time of day impacts. How if this storm occurs during the morning commute or evening commute, what's the impact going to be? Well, using the hourly temporal data, we should finally be able to take a shot at the time of day impacts. Another thing this is going to help out with is using hourly snow rates. Instead of the 6-hour snow rates, which kind of get washed out, we're going to be able to use the hourly snow rates. We're going to have more collaboration opportunities by using this version. We can extend it out as far as we want to, possibly to day 7. And we can pair this with the GWHO, the Graphical Weather Hazard Outlook, in the future as well. That's a potential option. This is an example of actual output from the MBM, or from the WSSI using the MBM deterministic model. So the code is written and it's capable of producing graphics from the MBM. So it's just a matter of figuring out the whole process and finding a home for that to display the graphics. So we're really excited about this moving forward. And then the last thing I'll talk about today is some of our summer work. We're really excited that the NCEP Summer Intern Program is continuing on this summer. We're working with Chris Long of Penn State, who's been really fantastic to work with. And this year, he's doing the yearly counting stats as we always have done, but a couple other really cool things we're doing. We're going to rerun some of the key cases from last winter using the IRMA or RTM A reanalysis to see how not only, what we can look at right now is how did the forecast verify, but what we're hoping to do is take these quasi-observational fields here and see what was the impact from these observational fields. Did those match up? So we're looking forward to getting into that here later this summer. And another tool we're going to work on developing is a CWA tracker. So we're envisioning this as a GIS tool that we can use to basically say, all right, the Pittsburgh CWA experienced 87 days where there was at least minor impact, and they had 47 days of snow amount, and 32 of those days were minor or limited, things like that. We're hoping to create a tool. Our goal is to create a tool that will be able to do all that on the fly. So that's something that's on our radar for this summer as well. So with that, I'll turn it back over to Steve and John, and thank you guys for your time, and I welcome any comments or questions.
All right, Joshua, thanks. That was really a tour de force, really excellent overview. So we'll pivot now to our Q&A portion of the VLab Forum. If you would like to ask a question, please use the raise your hand feature or type in your question in the chat box. And I'd like to start it off, Joshua, on kind of a clarification point. So is it true that this is an impact scale, but you're not actually verifying the impacts themselves? In other words, verification here is still based on the state variables, weather elements that come out of the models and so forth. You're not looking to see whether there were, road closures, school closures, icy roads, that sort of thing.
I'm glad you brought that up. So in a formal way, we are looking at so that's actually one of the things we're doing right now is every summer we sit down with our intern student who's gathered a collection of all the cases where there was at least a minor event, and we sit down and look at the LSRs and the storm data. So those are the only two data sets that we have that really talk about any of the impacts that we are able to easily access. So that's what we're able to do. So it's kind of a subjective verification based off of the subjective reports that we get, and we're able to do at least some kind of verification through that. Now, we're working to eventually come up with a way that we can do impact verification, but to our knowledge, it doesn't exist anywhere. So we're working to kind of build something that can help with that. And right now, the best that we can do is just use the storm data and the LSRs. Yeah.
So, and to some degree, the feedback from the users would indicate that the product has use from their perspective, and it must be verifying something meaningful for them to like it this much. But you nevertheless, you'd want to dive down at least for certain cases, and like the flash freeze in particular strikes me as a very tricky forecast problem, and one where if it does happen, it's really impactful. So those might be the kind that you would do deeper dives into in post-analysis to see if indeed those things happen and what was the impact or not.
Oh, absolutely, absolutely, and that's something we're working towards.
Okay, one other one I have for the moment here is sort of looking ahead. This is all at the moment based on the NDFD, and then you're moving into the blend. But in the real short time frame, it would suggest that there may be potential going to like 3D RTMA in an analysis mode, or additional information, particularly with freezing rain and that type of thing. If you have 3D information coming out of the models in particular, have you guys looked at that, thought about that?
We have not at this point gotten to that consideration, but in the future, that is definitely something we can take a look at. But we're not there yet.
yeah. Obviously, that's a challenging one, and would have obvious extension to aviation in particular.
Certainly.
John, do we have some questions from the audience?
Yeah, we have one from Ethan Burwell, and I think it touches on similar things that you brought up earlier, Steve, but let me go ahead and read it anyway. It says, it seems like the categories are based on observed physical impacts rather than climatological percentages. And he says, you mentioned some physical factors like land usage, but are there others such as school cancellations, road maintenance, or travel industry disruptions? And can you expand a bit more on the cultural impacts and factors that are used to correlate conditions to physical impacts?
Sure. I'll take a stab at that. Well, first off, one of the other things that I did not mention off the top that we do consider is population. So we do have, if you have a winter storm that's occurring in a densely populated area, we do have it written into the algorithm that you have an increased impact from population there. Now, we are not we're not using the live traffic data for as an example to kind of like live correlate impacts. We're not there yet. I think those are all fantastic ideas, and as this matures, we're kind of past the base level product that we're getting it to. Those are all things that we would be very excited to look into more. Right now, we're kind of just focused on getting this like base level product to be at a stable position, as good as it can be, and then we're looking to expand into those kind of areas.
Cool. I just want to quickly interject. I think Jim Nelson had a comment, and I unmuted him. I wanted to see if he can join us in our conversation here. Jim, can you talk to us?
Yeah, can you hear me, John?
Yeah, sure. Go ahead.
All right. Just to add up on the verification aspect, we're working with the performance branch to develop requirements for impact-based verification database. We also do, event reviews with the WFOs. They do a great job of detailing their events and see how it worked within the forecast office, how they could relay the message, as well as how the message was received by their partners. Some great examples have been out in California with the DOT, and also throughout Michigan, because Grand Rapids is a heavy user and briefs the whole state on a lot of their impacts. So we get a lot of feedback from those two areas throughout most of the events. But we do get, we have a national team, and there is a lot of feedback per event from a lot of WFOs.
I'll just go ahead and leave you unmuted, Jim, so you can chime in at any point. And Steve, if we have time, Paul Wallen would like to ask a question.
Sure, go ahead.
Go ahead, Paul.
Yeah, I have a couple questions. First off, you mentioned hourly, like snowfall rate, ice accumulation rates, etc. In the Forecast Builder project, we're working on that as well because it affects a lot of our calculations. It seems like right now a lot of things are tuned towards 6-hour QPFs, for example, the WPC, the NBM, that seems to be the gold standard. Have you looked at any ways to divide up the 6-hourly QPF into hourly blocks based on POP or any other criteria to get your snowfall rates, etc.?
Currently, we're not doing any disaggregation, but we are looking to use the, as far as the NDFD is concerned, kind of our first shot into the hourly realm is going to be with using the NBM deterministic to see if we can, test out those algorithms using that input first, kind of and go from there. But that's our stated plan as of now.
Yeah, and the second question is, it just seems like, and I think we might have talked about this before, it would be nice to get this, at least a preliminary, what WSSI would be out to the field, be if they're able to do the calculation with the hourly grids in Forecast Builder. I think that would be great. Obviously, you want to appear on the web pages, is based on the NDFD, that's fine. But I just think getting that calculation out to the field may help it be more looked at, and also maybe provide some feedback when they actually have time to look at their fields right on their GFE to see what it's producing. I don't have any idea
Sure.
about that.
Sure. Yeah, that's Jim. I can let you field that one if you want to talk AWIP stuff.
All right, I will. Yeah, Paul, those are, that's a great part of the forecast process. Obviously, I think the calculations and the base behind WSSI as far as its impact levels and everything is probably a little too much for GFE to handle, for every forecast database that point. And that's the process. So I think if you're updating your NDFD on that time, you have an idea of where you're at, and maybe if you change your forecast of how that affects WSSI as far as a national perspective is concerned. I think understanding, and this is part of the education and outreach of our aspect, is to make sure that everyone understands what the elements that go into and how it affects the WSSI impact levels. So I think running it locally, it would be a little bit too constraining to each individual 122 offices systems. That's just my perception at this point. So it'd be worth it. I think it'd be worth just trying to work with whatever forecast database we have and making sure that we give you the best information we can going forward, and tweaking, to run at a local WFO, I think would kind of we'd lose the robustness of WSSI.
Yeah, I mean, and I don't mean for national distribution, just even locally to see what's being done and maybe offer some suggestions how to improve it. Because I mean, in Forecast Builder, we're finding the best input always comes from the field when they have a chance to look at it, and among the various regions too, just providing input, that always seems to be a great benefit.
Well, you're more than welcome to give us some information about some events that you might have had, and we can rerun and go through those events and see how that helps inform WSSI to get better and better.
All right, thank you.
That would be, I mean, we've run through that with Boulder and a few other offices as well.
John, other questions from the audience?
That's all we have for now.
I guess I've got a follow-up, Joshua or Jim. So this is an index, and it strikes me that some users, decision makers, if you will, are quite happy with just the rolled up index, but others may want to disaggregate to see the different subcategories depending on what their particular decisions are. So do you envision kind of like a multi-tiered product where some may just be focused on the flash freeze part, and others are more interested in the snow load, and others in the blizzard kind of that sort of thing? So what's your experience with the right sort of presentation for the user?
Yeah, I'll start off here, and Jim, if you have anything, you can feel free to jump in. But I think I'm going to pull up the slide on our web page. I think that's a really cool feature about our web page is we give the user all of those options. So we have the overall impact as kind of like the home tab. But if you were to click on any of these other tabs here, whether it be snow amount, snow load, ice accumulation, you'll get that same image. but it's just focused on those specific components. So it'll just only show the snow amount image or just the ice accumulation image. And we've found that a lot of the briefers have used the overall image, but some offices like Omaha, for example, or even out in California, we've seen they'll just focus on the particular image that is the main event, if you will, for the day, whether that be blowing snow amount, or as you say, flash freeze. There was a great California example last year where the flash freeze index really highlighted where there was a couple of dangerous areas and major passes. So far it's been depending on what the offices, what their comfort level is, but we do provide all of the different options for folks to use. And I'll say as well, in the GIS data, we have individual files for not only the overall, but for each of the individual components as well. So those can all be added as different layers to a display on your own office's situational awareness views for GIS data.
Okay, and thanks. And then getting back to the really short, otherwise used, lately described as like high cadence IDSS. So do you have like an analysis capability that basically shows, the now WSSI, or is that something that, you envision as a new kind of product?
That's a really great idea. We currently don't have that. Our now cast is our day one imagery, but I do think that would be, based off out of the RAP initial field, or something that could be very cool, something that we could potentially develop in the future. I think that's a cool idea.
All right.
I mean, Steve, just to add, we are developing capability to use the IRMA to go back and rerun cases as well, just to make sure that, the WSSI is performing as expected. So that's a bigger push this year. So we can go back, and it's not just, we're not verifying the forecast, we're verifying WSSI, for these particular.
Yeah. Okay, John, do we have other comments or questions?
Yes, Dave Ruth just wanted to mention that the NDFD central server can produce 1-hour QPF mosaics. So I'll pass that along.
Oh.
All right,
that is good to hear.
Dave.
Thank you. Yeah.
And that's it from the user side of the house.
All righty. Very good. Thank you again, Joshua and Jim. Really great stuff. It's winter and summertime today. Great to look at this. And obviously there's this general approach, I think, has got huge potential for other types of phenomena that are present hazards for, it's kind of a no-brainer. And you guys are kind of, blazing a path for that. One can imagine a whole bunch of other sorts of IDSS focused guidance coming out of our forecast process and our models and our post-processing, like the blend. So I really thank you all, and excellent presentation, great work.
Thank you, Steve.
Thank you, guys. Thank you for the opportunity. Really, really appreciate it.
Very good. So reminder again, this session has been recorded, and we'll upload it. John Chattel will send out an email when it's up there, and you can share the link with your colleagues, friends, your grandmother, whoever you want. And we've got some other great talks lined up for the upcoming months. John, you want to run by those, the next two talks?
That would be a very good idea. I wish I had the, let me see.
I think in July we got Cam in the Cloud, right? Cam in the Cloud?
Let's see. So yes, it is by Arun Jalra. And then in August, we have automatic detection of weather fronts using deep learning neural networks by James Baird. And that will take us through the summer months, and then we'll have some other additional topics lined up for the fall.
Very good. Yeah. So tune in for those. Very interested to hear about the HPC cloud modeling effort that was funded out of one of the supplemental projects. So Arun will be giving us a tour of that. Hope you can join us for those talks. And if you have any other ideas for upcoming things you'd like to see, or you yourself would like to present something, just shoot an email to John Chattel or myself, and we can happily book you for an upcoming VLab Forum session. So with that, thanks everyone. Have a happy 4th of July and a safe one, and we'll see you later in the month of July.
Absolutely. Have a good one.